Okay, now let's talk about electronegativity. Electronegativity is the ability of an atom to attract electron towards itself in a compound or a molecule. Suppose these are two elements elements atoms A and B. These two atoms are covalently bonded. So electronegativity is that ability with which this atom nucleus will attract electron towards itself, and this atom nucleus will attract this pair of electron towards itself. So it's this tendency which is called electronegativity. While the value of electronegativity of an element describes its atoms' ability to compete for electrons with other atoms to which it is bonded. These two atoms are bonded. So this is the ability of this atom or either this atom. Whatever in these two atoms are stronger. If this atom A is stronger, so as you can see here, this atom A is not stronger as compared to atom B. So the electronegativity of B atom is stronger than the atom A. And that's why the electrons are much more attracted towards the nucleus of the atom B, which tells us that atom B has stronger electronegativity than atom A. So there are some factors which affect the electronegativity, and the first is the atomic size. You know the atomic size is you move from top to bottom in a periodic table in a group. What happens is from top to bottom the atomic sizes increases. So as the atomic size increases, it is normal atom 1 over atomic size inversely proportional to its atomic size. Why? Because the shielding effect increases with the decrease in the shielding effect. When the atomic sizes increases, the shielding effect increases, and as the increase in the shielding effect will decrease the electronegativity, and increase the electronegativity will increase with the decrease in the shielding effect. That is, the atom is inversely proportional to the shielding effect of that atom. So this is one factor which affect electronegativity. The other factor is the effective nuclear charge. So suppose if this is an atom nucleus and you move from left to right, what happens is in a period when you move from left to right, what happens? The positive charge in the nucleus increases. So if the positive charge increases, it means that this electron which is present here or which is bonded to another atom which is shared by another atom in a covalent bond, this positive charge, this much positive nuclei will attract this bonded electron towards itself more. This is called effective nuclear charge, is directly proportional to electronegativity. Increase the charge in the nucleus and the electrons will be much more closer toward that very atom which has the higher effective nuclear charge. Okay, now increases electronegativity increases with the s character of the hybrid orbital. So again, this is the similar with the nuclear charge, that if atoms are bonded and their s orbital which is closer to the nucleus, first s, then p, then d, then f. So if the electrons are closer in the hybrid, or we can say that if the electrons are in the s shell, if the s shell is involved in the bond formation, then electronegativity will be higher, or the electrons will feel much more force by the nucleus. Bond order is directly proportional, also proportional to electronegativity. So bond order electronegativity of the single bond will be less than will be greater than the double bond, and double bond will be greater, electronegativity will have greater electronegativity than the triple covalent bond. And the next is the oxidation number. Oxidation number is directly proportional to the electronegativity, which means is that Fe3 will be greater than the Fe2, and Fe2 plus will have greater electronegativity than Fe. This is the oxidation order or the oxidation state of that atom. And electron negativity does not depend on stability of fully or half-filled orbitals, because electron negativity or electronegativity is this tendency of an atom with which that atom's nucleus attract the bonded electron towards itself in a molecule. Like this is, if we consider this is a hydrogen and chlorine. So we see that chlorine has higher electronegativity than hydrogen. That's why electronic pair is much more closer to the chlorine than the hydrogen atom. Hope this makes sense. See you in the next video. Take care.